In problem 3, we're asked to calculate the molecular mass or the formula mass for these different molecules. And so you'll need to look at of course, the average atomic masses in your periodic table. I use ptable.com numbers. And you want to look at the subscripts for the different elements in your compound. So this is not a compound but an element, but there's 4 phosphorus atoms. So the way we calculate the average the molecular mass for this substance is by multiplying 30.974 by this subscript of 4. So if you punch that in on your calculator, you should get 123.896. And that's in units of grams per mole, or units of AMU. Okay. For the H2O molecule, the 2 here refers to the hydrogen. And we have just 1 oxygen. And then once you calculate the masses from each of your element types, you add them all up. So on my calculator, I'm typing 2.016 plus 15.999, and that gives me a value of 18.015. And I will just choose to write that in AMU. Okay. For part C, this is a larger molecule, and you need to watch out for parentheses. When you have something like this, that's equivalent to 2 of these guys. And of course, that balances out with the +2 charge, so that's why you need 2 nitrates in this ionic formula. So in total, there's 1 calcium atom, and the average atomic mass of calcium is 40.078 grams per mole. And we've got a total of 2 nitrogens. So basically, the 2 multiplies the unshown subscript of 1 of the nitrogen to give you 2 nitrogens. And on ptable.com, your periodic table shows a molar mass or an atomic mass of 14.07. So you multiply that by 2. Okay. And for oxygen, we have 6 of them. So what you want to do is, the 2 and the 3, there are 2 nitrates, and each one has 3 oxygens. So that's where I'm getting this value of 6 here. So there are 6 total oxygens in this formula, each of which has an average atomic mass of 15.999. So you need to multiply that number by 6 to find out the total mass of those 6 oxygens. And then once you know the masses of all the calcium atoms and nitrogen atoms and oxygen atoms in your formula, you add them all up. So let's go ahead and do this here on our calculator. Okay. And as a general rule, you never round these formula masses off. You just leave it with all the digits there that you've gotten, okay, based on the precision of the periodic table. So that's the formula mass for this ionic compound, 164.086. For molecule D, we've got acetic acid, a component in vinegar. And you've got to be careful when you add things up here. This molecule has 2 carbons. The C is written in 2 places. And there are 2 oxygens. And let's switch maybe to yellow here. There's 3 hydrogens here and 1 hydrogen here. So a total of 4 hydrogens. Okay. And then, as usual, you want to add up the masses of all the carbons and oxygen and hydrogen atoms in your molecule. So 24.022 plus 31.998 plus 4.032 gives us a total mass of 60.052, and we could write that in units of grams per mole. Sucrose, that's the active substance found in sugar. So, or we just sometimes call it table sugar. So we've got 12 carbons, 22 hydrogens, and 11 oxygens. So these will be quite large numbers here. And the molar mass, or the formula mass, or the molecular mass of this compound, it's going to be quite large. Okay, so for carbon, we have a total mass of 144.132 AMU from all those carbon atoms. For hydrogen, we have 22 of those. Coming out to be a total of 22.176. And for oxygen, we have 11 oxygen atoms. And again, the periodic table will give you these numbers. I'm using ptable.com. And that gives us a 175.989. And then you want to add all these up. To give you a total formula mass. So 342.297, and I'm going to choose to write those in units of AMU. So that's it for this video. Thanks for watching, and please consider subscribing.